Welcome to the Dapr community call on November 10th. Glad to have you all join. We got a few topics today that I think are pretty interesting. And as always, feel free to drop questions in the chat and raise your hand to be unmuted. We'll try to get to your questions, but we're definitely going to leave some time to just have discussions and questions about anything at the end. Today we're going to start with Yang Bu showing us high availability mode for the placement service. Then Mark is going to show us a demo of hardening an application with Dapr, which is pretty cool. And finally, David is going to show an interesting use case of using Dapr in GitHub Actions, which I think is also a kind of a cool demo. So yeah, without any further ado, let's kick it over to you, Yang Bu. Let me stop sharing.
Oh, thanks, Ori.
Okay.
Oh, thanks, Ori. We have made lots of changes in placement service and an actor building block in this milestone to improve the reliability of the placement service and actor. So today, actually, we're going to introduce like a new HA highly available mode for placement service. Before doing a demo, actually, I would like to briefly explain about what the placement service is. So this is the diagrams is on the Dapr docs websites. Basically, if you are really interested in how the placement works and what is the actor, you can take a look at these docs. But I would like to briefly introduce what is the placement service is. Placement service is one of the control plane service in Dapr, and placement service is used only for Dapr actor building block. So it has two roles. The first role is to maintain the membership of the Dapr sidecar. So when the Dapr sidecar started, Dapr sidecar, Dapr runtime, it will talk to placement service, and placement service will register these particular members, the Dapr sidecar as a member, and then what happens is it generates a distributed hashing table and disseminated this hashing table to each Dapr sidecars. So there's two roles that I said. One is the membership maintenance of the Dapr sidecar runtime sidecars, and second one is to generate the distributed hashing tables. So, but right now in the current implementation, when we deployed the Dapr with the high availability mode, you can see that. Okay. I already deployed the Dapr 0.11.3 to my cluster. So if you deploy the Dapr with the high available mode, you can see that the placement there's only one placement service instances. So that which means if the placement service is down, then there is no way to handle the request from the Dapr runtime. So, and then once the placement is started, restarted, and then Dapr sidecar will try to talk to the placement service, and then will register placement service and reconstruct the distributed hashing table. So, but the problem here, the placement service is storing all the membership list and the distributed hash table in memory, so that if the placement service restart or crash, then the state is gone. So let me show what happens if I restart the placement service in the Dapr sidecars. So I was just streaming one of the actor applications sidecar logs, and you see this one. You can see the logs here. This is from Dapr sidecar, and then I will just like delete Dapr placement service, and it will shows what happened. So if you take a look at this log, basically it will try to reconnect to the placement service, new placement service. And then, okay, now it's the placement service start. And then what happened here, I deployed this state actor application 30 pods. So if you take a look at that, the pods, 30 state actor application pods are running. So what happened is, once the placements are started, these 30 applications try to connect to the placement services. And while doing so, placements start to register each Dapr, each application, and then it will generate the distributed hashing table whenever the application is registered into the membership. So that if you take a look at this log, Dapr sidecar will get over 30 table updates. But this is okay. I mean, if eventually you will have the same the distributed hash table for in all the 30 in all 30 state actor Dapr sidecar, but while doing so, if the Dapr while doing so, active clients calls the actors, then what happened is Dapr will try to activate it in a multiple Dapr sidecars, activated actors and multiple Dapr sidecar. It will result in multiple actor activation. It will eventually will be consistent, but this can happen. This can impact the to the existing production environment. So it will have some sort of like some failures while like making an activations. And also we found some issues related to reliability of the placement service. While disseminating the placement service to the Dapr sidecar, we can see some sort of like crashes because of the memory and the CPU usage. So to resolve this issue, we basically leverage the Raft and to enable the multiple replicas for placement service and enable the leader elections. And also using the Raft consensus algorithm, we can share the same state of the member list and distributed hashing tables. So that once the leader is down, even if its leader is down, another the replicas will be a leader, and the leader will have the same state of the member list and then distributed hashing table, so that each application will not get any table updates. And then even if during the so it will basically resolve the issues related to double activation of the actors. So let me show how it works. Okay, so let me switch the context. Dapr system. I deployed a new Dapr to my test cluster, and then if you take a look at this one, basically the new one will deploy the three instances for placement service. This is a stateful set, and one of three will be a leader. So let me take a look. Let me find which one is leader now. Oh. So this is not log is very, very verbose, but this is because of I enabled, I set the log level is debugged. now is the leader will be the first instance. So let me try to stream the one of applications sidecar logs. So this one is the sidecar logs, and I will try to kill the pod. Kill the leader. So, and then, oh, sorry. Then if you take a look at this, and while doing so, you will try to find which one is the leader. So, yeah, and then you find the one of the new leader, and then we'll try to connect it to the leader. And then if you take a look at this one in the first logs, basically in the first dissemination, there is no update, but the second dissemination, if you look at this one, there's some updates here, but this one is the bug that I found in the early morning, but we will fix this issue. But when we release the next version of Dapr, we're gonna, we will fix this issue. So if you take a look at this one, so as compared to this one, we can see that there was a 30 table updates whenever the new whenever application register in the placement service. But the new one, basically, when we kill the leader, we don't see many table updates here. So this is basically, sorry, this one is the bug. We will fix it before release the next version of Dapr. Yeah, that's all. Yeah.
Great, thank you, Yanbu. Definitely a good step forward with resilience for Dapr, especially for folks using actors. Pretty important addition. Yeah, Mark, let's move on to you.
Right, let me start sharing this. So I think from almost day one, when we put out Dapr out there, we kind of put a lot of emphasis on being super easy to start with. And we have a lot of applications, demos, and it's really easy to kind of build the initial application. And obviously over time, people increasingly start deploying these applications, and now a number of customers are already running these in production workloads on those. So we want to kind of increasingly start covering some of the more operational challenges around managing Dapr applications and protecting them and so forth. So today we're going to cover the kind of access control and scoping for components and other things. So let me see if I can.
Mark, I don't think we're seeing your screen if you're sharing.
Oh. Well, that's not good. How about now?
Okay, yeah, now we see it. We see a slide.
Right. It always helps when you click the share button. All right, so today what I want to do is kind of not go through the whole entire laundry list, because there's actually a long list of features that have been introduced with every release, but just kind of focus on some of the basic concepts that are required to kind of when you're wanting to run application in production. Whether you're running this in a multi-tenant environment, soft multi-tenant, which is like inside of your company, so different departments, but it's kind of separated, or whether you're running on a standalone mode, you still want to have some precautions around controlling your application. So a couple of things I want to cover is just kind of per application component scoping, both with regards to, by the way, is this menu kind of, there we go. Both with regards to the being able to designate which components can be accessed by which application, being able to control the pops-up API and kind of allow certain applications to only subscribe and some of them only to publish to a particular topic. Obviously, secrets is a key component of that. How you, not only from a standpoint of enabling application to secrets to be accessed by application, but also controlling which secrets that application can access. If you're really concerned and paranoid, or if you're exposing your Dapr API publicly, you probably want to use the token authentication we provide for both HTTP and gRPC protocols. And with the latest release with V11, we also added support for spiffy identity. In fact, that's by default how Dapr is identifying its services. Open policy agent policy support is like duplicate on policies, I guess. And in that space, there's a whole area around like a service-to-service invocation and verification, like knowing full well what is the identity of the service that is being invoking you on your service. We can do that using management of relationships between these, using logical domains. So whether you're running Kubernetes using namespaces, whether you're running somewhere else, we can use like a logical identification of different groups of applications so that there's no collision with names and so forth. And then if you also want to probably get to the point where you're getting very granular, basically denying everything except explicitly allowed activity. In case, for example, of a service, it could be deny everything except a post, so a specific verb on the particular operation on the particular application. So what's my page switching doesn't work here. All right, so what I want to demo today is definitely real world representative kind of a demo, but it obviously it's kind of a shortcuts around the application. So there's no real logic per se, other than maybe some formatting and counting. But you'll be able to reproduce the entire demo yourself after I finish, and I provide a short link because those GitHub URLs tend to get pretty long. But what we're going to overview here today is a Dapr application deployed in Kubernetes that it's exposing a single service externally using nginx ingress. And it's actually ingress point that it's protected with HTTPS and certificates, and it has its own identity. So we're going to expose this one service over here to the external calls. We're going to then use this service to reformat the incoming request into a different structure and pass that request to a application 2 in here, which is going to be able to use secrets to connect to Redis that's going to be used as both the state store and topic management, or pops up for topics, or topics for pops-ups, sorry. And then it's going to pass the payload all the way to a third event, to a third application that's going to be subscribing to the topic, consuming those events and doing some basic log output, also having access to that Redis key in here. So it's pretty demonstrative of the type of things you would want to do: cross namespace invocation, protection of access, invocation of data services that might be in or outside of the cluster. Obviously, it's a kind of a synthetic application, but it's representative of the real world scenario. So let's go over here. First of all, what I'm gonna do is kind of go through a couple of examples. So in case you're wondering, how do you make nginx or any kind of ingress Dapr for most of them, Contour or nginx or others, you basically, during the installing of the Helm, there's usually a flag that allows you to include an additional file, which kind of does a patch on the deployment. So in this case, we using the basic Dapr principle of using the annotations on a pod that will make a couple things. There's obviously enabling Dapr itself, giving it a name, making sure what it runs. So if you're interested, there are some demos I'm going to point you to later too. But the other thing we're going to do is we're going to take a look at, for example, at state component in here. You will see the first thing we do is we don't include the clear text passwords in here. We actually, depending on the implicit component that's loaded by Dapr when you're running on top of Kubernetes. So we don't even have to configure it. But what it gives you access to is the actual Kubernetes secrets. So in this case, we have a secret in here that is being created called Redis secret. And inside of it, there is a key called password. And we're going to be using this to access the Redis server that's been deployed inside of the Redis namespace. The one thing to point out in here that we actually using scopes on a component itself, saying that only the op2 is able to access. So just quickly switching over here, we're saying only with regards to this state, only the op2 is able to use this component or this secret. Sorry, this component. Similarly on PopSub, also we're doing secrets just like we did before. Also we're using scoping. So we're basically saying that only these two applications are able to use PopSub because they communicate with each other. But in addition to that, we're saying that op2 is only able to publish 2 messages, and op3 is only able to subscribe to this messages topic. the messages might be low overloaded, but basically it's the name of the topic. So op2 is publishing, op3 is consuming, and that's all they can do. On application level, first of all, we are using a config annotation to designate a specific configuration for that application. And then in the configuration itself, we do a couple of things. First of all, we have the access control policy implemented in here. So first of all, we deny all access to that service all over. We are assigning it a particular trust domain. In this case, I'm using the name of the application, but it could be anything that you want to share between us, trusted as a logical separation. And then we have one policy for this one service. So we're saying for app ID nginx ingress, so this is again the one coming from the default namespace, we want to deny everything, first of all, so make sure that nothing can come through except a ping, post on the ping method that's going to be allowed in here. Then we follow the same principle with all the other ones. I'm not going to bore you through this, but basically saying one can only invoke in here, deny everything. We're using the namespace set designation with trust domain, and we allowing only counter, which is basically counting the responses. And op3 has a minimal policy because there is no actual method exposed. So it just has access to secrets. We're saying this service can access only this one secret. What this allows you to do is you have developers deploying applications into multi-tenant environments. You might not be trusting them always that they're going to be reading only their own secrets. Maybe there are some other ones that you don't want them to have access to. So this is a very defensive posture in here. All right, enough of YAML. Nobody ever was excited about that portion. So let's go through this. So first of all, what I'm going to do is I'm going to run a simple curl command, posting my very basic message to the message topic to the service over there. You notice I'm going to using an API token that I retrieved before, and I'm going to be invoking the externalized Dapr API that's on the ingress itself. So what we're going to call here is, where's my PowerPoint? What we're going to call here is this actual point in here and use this to find, discover the service that's over here in this namespace and connect to it. So let's run a quick call. This was pretty fast because it's already warmed up. As you can see, I have exercised this a lot over the last couple of days. There's 322 invocations. You will see a response to 100. You will see also some trace ID that we're going to come back to later. Basically, everything worked as intended. What I want to show you, though, is if, just bear with me here, too many tabs open here. If I went to in here and invoke the op2 application in the namespace called Harden directly, what would happen is Dapr would respond with an error. We're working on this. This should be really a 300 level error, but we'll fix this. But basically what comes back here is that the direct invocation of this service was not permitted. So you see the full error in here. So basically everything worked as designed. The other thing you might be wondering, so hold on, Mark, how about if I'm not exposing my service externally and I want to really protect those inside of the namespace itself? Like let's say there is another application running another namespace. So let's simulate this. Actually, let's not do this in this tab. Let's simulate this in here. What I'm going to do is I'm going to connect to the opt2 pod port forward so I can run the local Dapr API on that pod. Hopefully that runs. There we go. So then what I can do is I can come in here and, forgive me, what I can come in here is, that's annoying. Just give me a second. There we go. What I can come in here and actually invoke directly the API in the pod itself. So this is simulating somebody actually getting access to your pod, to another pod or another namespace and invoking the Dapr because they know what this method is. So when you see, for example, is that even though I was able to get into the right namespace and I know the name and everything, where I come from is not the right place. The policy explicitly prevented that from happening because it said deny everything. So that kind of gives you a good idea of how we can control this. And you can do this also for namespace for topics. So let's do another thing in here. bear with me. What I'm going to do in addition to this, while we have connection to the other one, I'm going to try to actually publish directly to the topic that I am not permitted to for this particular application. You see also an error preventing me from doing this. So let's do one more thing very quickly. I think I'm running out of time here, but I'm going to start sending, where's mine? I'm going to start sending, let's make this a little more aggressive, 500 requests, one every second. And open a new tab in a browser in here. And go to the namespace to kind of give you a little more visual to Zipkin for the tracing, so we can get a better visualization of what actually is going on in here. The one thing you're going to notice, and this text, I wish there was a better way to making this easier. What you will quickly see is, actually, let's this one on top. You will see this more bulk of the traffic is going to up 1, up 2, and the couple errors that I've invoked before are represented as red dots in here. I didn't do anything in here. This was inject the trace IDs for these applications, including the trace ID from the ingress itself. So this is not only the applications I wrote, but the ingress itself was able to inject the trace ID, and the trace ID was carried by Dapr throughout the entire process. So this is super easy because this is direct invocation, and this is invocation of a service. But what actually happens between up2 and up3 is we publishing to Dapr pops up API. And Dapr pops up goes through the Redis queue and all that. Still, we are able to recognize that these two things are connected. So hopefully this kind of give you an idea of the type of customization and control we have in Dapr to enable you. And most of those things are kind of to a large degree hidden from you and automatically enabled. MTLS between new applications is by default. Kubernetes secret support is automatically there. You don't have to do anything. But if you want to tighten that control, there is a lot of options, and there's even more so that that I have shown. One more time, this entire demo with how to reproduce it and to rerun it yourself is available here, bit.ly Dapr-harden. You can follow those instructions there. If you have any questions, let us know.
Great, thank you so much, Mark. I think this is pretty awesome. It kind of brings together all the security features we've been talking about and showing it how they come together. Yeah, I'm not seeing any questions, just some good responses from on the chat. But yeah, feel free to ask more questions also later on once we finish with all the demos. Yeah, so thank you again, Mark. And David, the floor is yours.
Thank you. I will also have to remember, like Mark, to share the screen. Okay. So thanks so much for the opportunity to chat. Can everyone see my deck right now?
Yeah, we see that.
Okay. So I'm really excited to join the Dapr community. For those that don't know, I have a lot of experience in open source communities and in Kubernetes and Kubeflow, and I really couldn't be more impressed with how far everything has come so quickly with Dapr, the flexibility and things like that. There's so many hallmarks of a great community already going. As I mentioned, most recently I had been focusing on machine learning and Python in particular, and Dapr obviously has an SDK. But one thing I'm really wrapping my brain around is the idea that Dapr is a great distributed runtime, and it solves a lot of really core problems that people have when it comes to these distributed applications. And I think that workflows are basically a special case of a distributed application. And by that, I mean, if you think about a standard 4-step workflow here, for example, you might have something where you want to retrieve a secret. Then maybe you have multiple workers that you would want to spin up and, write to a single state store and, deal with concurrency issues. Then you retrieve the winning state and fire off a long running job. And then maybe you have a final step where you retrieve the results of that long running job. And you can see it here. Obviously, this is a very toyish diagram of it. But this is certainly something that I was running into quite a lot in workflows that I was running, whether or not they were inside Kubeflow or in standard CI/CD tools like GitHub Actions or Jenkins. So what I wanted to do was to see if we could try and use the tools that Dapr already provides to help solve that problem. So let's pop over here. I have here a very standard workflow. For those that haven't seen, this is what you write GitHub Action workflows in just straight YAML. And you can see here, this is a workflow run. At the beginning, I set some environment variables, pretty straightforward. I set the environment. And then here you can see what I do is I actually download and install Dapr right in line, and then set up and run it. Again, right in line. Now I put it into the background, so now it becomes a service that anything can run. And what this does is it means that each of these individual steps can now use the Dapr functionality natively. And I'll show you how that works. So like I said, I tried to exercise some of the Dapr content. I'm actually going to kick this off. Hi, community, because it takes just a second to run. So we'll get that going. Hit a community demo. Get push. Oops. And so off it goes. So like I said, in these steps, you can see how trivial it is. Here, for example, I'm able to retrieve the value from a state, or in this case, save it, in just one command. Again, I don't know anything about this. I'm just an average Python developer, or maybe even a great Python developer. But I don't want to think about how having to read and write into state stores, binding, Redis or Cosmos DB or whatever state store I'm using. I just want to be able to save it. Here you can see I'm executing a multi-threaded workload. And in this case, I'm simulating that by, or simulating multiple workers by doing job outputs. And here, all I need to do is use the E tag that's provided to me, as well as this consistency state. And it will fail on everything but the first one. And then in the third step, I'm going to create a consumer here using just an annotation and spin that job up, and then also a publisher. And in this case, I just published this. Now, obviously, this is all just for the sample to exercise different components here. You might want to architect it differently. But what you don't see me is, as a distributed application developer using Python, I don't have to do anything particularly complicated here, right? I'm just using the Dapr tools that are available to me. So let's pop over to GitHub now. Here's the repo. It's all public and available for use. You're obviously more than welcome to go dive in. One thing I did was, here I have some sample components in here, but obviously that's not what you would want to do. You would never want to publish your real components. So what I did was I actually put them, each of the component configurations, into a secret. And this workflow here automatically, using this very simple Python file script I wrote, copies those secrets and drops them into a directory called component. So which Dapr obviously picks up. And now here we are. The demo actually went faster than I thought. I thought we'd be able to see it on the fly. But you can see here I ran it. Here I simply set it up. Here's me setting up Dapr, and at the end of it, running it. And you can see that here. And now it just sits here. It's up and running. It's on that port that I had specified earlier. And now inside of Dapr, inside of my workflow, I'm able to read and write from a local state store. Here I am. I run a job that has contention, where only the 0th thread should be able to write, and in fact it does. Every other one fails. And in the third one, I start that consumer. You can see that here. Here I publish that message to that endpoint, and then down here you can see, after the publish was finished, the consumer, let me see where it is here, picked up the long running job. Where is that? It's somewhere in here. But you can see clearly it picked up the long running job and finished it out. So at the end of the day, then it stopped Dapr and finished off. So at the end of the day, what I'm trying to get at here is that Dapr offers a bunch of really core functionality to these workflow producers and consumers, and they're just ready to go without any kind of complexity that would normally be surfaced in writing a distributed application. And that's it. The demo is there. You're more than welcome to copy and play around with it. Obviously, it's very hacky, but I'm more than happy to do this. And one thing I think we can do as a community that would be really interesting is this code here, the Dapr workflow step here at the top. I think this would be great to drop into a GitHub action where these environment variables could now be entry points, and then I can simply choose whatever I want and have it go through and then make it available. And with that, I'm done. Any questions?
Very cool. Thank you, David. Actually, before you showed that, I never thought of trying to use Dapr inside GitHub Actions, but I guess that's even like a bigger proof of it can really run anywhere. I mean, just a worker of GitHub Actions. I think it definitely opens some really creative things you can do with it. So thank you for that.
Yeah, thank you.
Oh,
sorry, go ahead.
Go ahead. No.
Oh no, all I was going to say is, this is definitely a little bit hackier than I would like. Obviously, we've gone through a bunch of iterations here. One thing that it would be interesting to explore as a community is if we want to offer just a Dapr D running in a container. Right now, it makes it very easy to get Dapr going by doing Dapr init. But if Dapr D was in a container and I was able to mount variables into that container when I first started it, that would have made this even easier. Now, again, there are a lot of problems there, namespace resolution and other things that we would have to solve for, but that would make it quite portable.
Yeah, definitely opportunities to make it a little less frictionless, maybe. Yeah, I'm just seeing a lot of nice comments in the chat, but no questions so far, as far as I can tell. But with that, we are, I think, done with the demos and happy to answer any questions that anybody has about anything. So pretty quiet today. If you want to be unmuted, feel free to raise your hand. Oh, I see someone. Oh, Kai is just clapping. Sorry. But if there's nothing else, then I guess we'll close a little earlier today. As I said before, we're recording this and this will be made available on YouTube. So if you want to kind of explore these demos again, feel free to do that. And yeah, and as always, we can go on, feel free to come on Gitter, engage on GitHub.
David is asking a question.
Yeah, if you could.
Oh, I'm sorry.
Maybe. Yeah.
On the JavaScript SDK. Any maturity around that? No, the JavaScript SDK, we haven't really had so much involvement with that one just yet. It kind of hasn't, we haven't been pushing it too hard at the moment with some of the customers that we're working with. We've mostly been focusing on sort of the other four SDKs. But we're more than happy for someone to kind of love to pick up and kind of contribute if they see that as being useful for them. We'll probably get to this probably sometime next year a little bit more, but not at this moment. We're not putting so much time into that one.
Yeah, I have some more context around the JavaScript SDK. So what we're looking for the SDK, and that's really for anyone who just want to help with that. We're looking for an API design for how to handle, the dreaded callbacks and which promises library to use specifically. And whether to use async await or not, or stuff like that. So it's really about how to design the API surface now. I think once that discussion has been decided upon, then we can move to the next step of actually implementing the SDK, just like the other more mature SDKs. So if anyone wants to help in with that, you're more than welcome.
Yeah, and I think there's another question here about community chatting tool. I assume Xavier, this relates to what we talked about last time, where we maybe want to change it from Gitter to something else. We haven't made any decisions yet. But yeah, I don't know if anybody else wants to chime in. People who maybe have not been on the call last time or since then have some thoughts.
So yeah, if anyone has any special feelings about Discord or Slack or whatever communications tool you think that the Dapr project should adopt, please let the maintainers know. And you can also write it here in the chat window, what you prefer. Yeah, Discord, you guys like Discord? So what do you feel about, Discord being really game oriented? I mean, I haven't used Discord that much. It certainly is hard to catch up on Gitter, Kai, I hear you. It's impossible to search in there. That's definitely true. Yeah.
Yeah, lots of other communities are using Slack. I think there is a growing use of Discord from what I could tell. For like upcoming GopherCon, they're using that also to talk to people.
Yeah.
And some other projects.
I had a quick question, a separate issue, if that's okay.
Yeah.
Sorry, I literally can't figure out where that stupid hand raise is. Otherwise, I would have done that. You saw here that I did the. Oh, there. That's exactly what I was kind of trying to get at. Thanks, Joseph. So I co-founded Kubeflow. For those that don't know, people are not using it natively today. But one of the things that I'd love to take on is helping to figure out how other platforms to take this Dapr to. And I think there's enormous amounts of opportunity. You saw me do it with GitHub Actions. If folks know other CI/CD tools, Tekton, Spinnaker, Jenkins, whatever, I'm more than happy to help there. But I really do think it exists. Dapr as a tool should be available anywhere someone writes code. For better or worse. There's obviously some things about how to surface components in those areas, but at the end of the day, if we're able to just simplify the use of these very complicated constructs, I think that'd be really positive. So that at the end of the day, after all my words, all I'm saying is like, if you have thoughts about creative places that you'd like to solve common distributed components, please reach out to me. I'll type my email address here in the chat, because I'd love to explore that with you and produce examples or help whatever your platform is get better.
Oh, I like that name.
Question
Data
about
mesh. Nice, Joseph.
data mesh, yeah. Joseph, do you want to, let me try to unmute you and maybe you can speak to that.
Yeah, I'm currently investigating using both of those components at the moment. We've implemented Kubeflow for our ML ops, and yeah, we're looking at implementing a data mesh basically for, I guess for properly monetizing and how we are surfacing our data as a separate project at the moment. And we're looking at using Dapr. We already have the ML ops pipelines in place using Kubeflow, so it seems we're early in our investigations, but it seems like a very easy and nice fit for us to just build on top of what platform we have in place at the moment with Kubeflow.
That's fantastic. Feel free to contact me offline about this, and
cool.
I'll set up an hour and we'll figure out how to work together.
Brilliant. Thank you.
Nice. Any other questions? Maybe that I missed. Okay, not seeing anything. Yeah, so thank you everybody for joining. Thank you for our presenters for presenting. By the way, if you have a cool demo, a cool scenario, or something you want to show on a future community call, feel free to reach out over on Twitter, either to the Dapr handle or to me, or Zohar, you can find me there as well. Or Gitter, again. Happy to see some more creative stuff from the community. Same goes, by the way, if you have interesting ideas, you know, we have a blog now. If you have some things that you maybe would like to share in the form of a blog, happy to work with you on that as well. We'd love to get more community contributions for that stuff. So thank you again, and hopefully see you all in 2 weeks for another community call. So thank you.